Hello, welcome to this lesson of the Introduction to Solidity Programming presented by Coding Bootcamps. This is going to be more of the constructs of the Solidity contract. We've already covered this information, and we've already covered this information. So up until so far, we've had our introduction to blockchain, and we've also had our introduction to Solidity with the remix environment. So now let's take a closer look at some of the constructs in Solidity. The pragma. So we talked a little bit about the pragma. The pragma keyword is used essentially to call the compiler. There are different ways to structure the pragma. So you can use the greater than or equal sign, which means the compiler version has to be between greater than and less than or equal to. Or you can use the caret that says the compiler version will not be earlier than a particular version, or you can set it to be exactly equal to. You can see examples of the pragma right here, and that has to somehow be consistent with the compiler we use for our Solidity code. Also comments. As we know, documenting our application the right way includes comments, and these are the pretty typical types of comments where we have the double slash, as you can see here, or the block comments with the slash star, as you can see an example here. Booleans. I'm sure you're familiar with Booleans, so Booleans can be either true or false. Booleans have a list of operators, including a negation, logical conjunction, so double dollars, and logical or, equality with the double equals, or inequality. And then integers. So integers are signed and unsigned. Signed integers can be negative, so that is the big difference between signed and unsigned. And integers can have different sizes. So we can see here we can have from anywhere from an int of 8 up to 256. The integer operations exhibit the same functionality as Java, C++, or JavaScript. So we can see here the int operators less than or equal to, less than, equality, inequality, greater than or equal to, and greater than, and the arithmetic operators. We can see here all of the arithmetic operators such as subtraction, multiplication, division, modulo, and exponential. So for a contract here, when we are declaring our variables, you can see here they are declared. In this case, some are initialized, some are not. And sometimes they are declared within functions, and sometimes, again, they are initialized. Strings. So strings are a special type of character arrays. Strings must be inside quotes or double quotes. So you can see here some examples. Strings cannot be directly compared for equivalence. However, the hashes of strings can be declared. And the supported escape characters are pretty typical escape characters: new line, new tab. An address. So address is now a different data type, so we're really getting into Ethereum here. And when we're talking about the address data type, it is in an Ethereum address. And addresses can also have operators. There can be two types of addresses: address and address payable, and we'll get into that a little more. You can see here there's a less than or equal to, less than, equality, inequality, greater than or equal to, and then greater than. And we can see here the address. Some addresses, particularly how the contract is run, come with our simulated Ethereum node within Remix. So we can go up to this drop down under account, and you can see here various addresses. Some of these addresses look like payments are going on. So you can see here, this one is a little bit below 100 Ether, and this address here is now up to about 103 Ether, while the others are still 100. So this looks like some kind of payment has been happening. Enums. So enums are an example of a user-defined or custom data type. enums are zero indexed, and when an enum is declared, it is declared with its name and its type, and the enum is initialized at the constructor. So when we initialize within a constructor, so you can see here an enum user options, and we can see the various user options here, with the first option being a 0, and then the second option be a 1, and the one after that would be 2, and so on. And so we can see here that when we want to set our options, we want to run the constructor or run this function, we're actually updating the value of my option. So at one point it is set to connect. So we can see here that my option will be set to connect. And a little bit about some special Ethereum type of operations. So Ether units. So Ether can be subdivided. It can be subdivided quite small. So we can, interestingly enough, in Solidity, Ether is based on the way. So you can see here the way is the unit 1. And a Zabo is a way raised to the 12th. A Finny is a way raised to the 15th. And an Ether is a way raised to the 18th. A few things, a few properties of the blockchain that we can return. Blockchain hash, block hash. Block Coinbase is a that would be associated with an address payable. We can return a gas limit, which would be a unit. Block timestamp. So this could be important. We could use this quite often as far if we need the time of some actions. We can send data back and forth, message data. We can get the sender of a payment. We can get the value. And we can also get the origin of a transaction and gas price. So please, there are more than this. So please look at your Solidity and your Ethereum documentation for a list of block and transaction properties for the full list. Arrays. So arrays are work again the same way as they do with Java, JavaScript, and C++. Arrays are data structures where one variable contains multiple values, and they can be fixed size or dynamic. Values can be added or removed from an array using a push or a pop, and arrays can be built from structs or native data. So we could have an integer array, or we could build a struct like a student struct and have an array of students. And a struct, again, is what we use to model, one of the ways we use to model real-life objects. Control structures, as you would expect, are if-else, while, do, for, break, continue, return. All of these work the same way that they do with Java, JavaScript, C++, and others. And we can see in here, here's a struct for a customer. In this case, we are saying a customer has a first name, a last name, and an email. And with this function here, we are passing in a first name, a last name, and an email. And we are pushing customer the customer, which is a struct, onto the array called customers. So if you can see up here, we declared a customer array. And right down here using this function, add customer, we are building that array. And you can see we're also removing it down here. And you can take a look here at some of the other code here and what exactly this is doing. Here's our exercise. And this is a little hard to read, but if you go into your learning materials, you should be able to copy this out. Just make sure your pragma and your compiler are consistent. You may have to update these, but we have an enum in here. We have a constructor. We have a function here for the enum and to update it. So let's take a look at this. We can see customer addresses here. So obviously the name of this contract is customer contract. And here's the exercise here. So we're going to use Solidity. And if we need to follow these steps. One thing about Solidity is It's highly high. Well, I shouldn't say Solidity. I should say all smart contract programming. So it doesn't have to be Solidity. It can be Go. It can be JavaScript. So it can be the other languages. Anytime you're building a smart contract for any kind of a blockchain, Hyperledger, Ethereum, you name it, they're highly, highly role based because we have parties interacting and value exchanging. So right there, that is going to require roles. So sometimes you might have to really get a good understanding of the actors and what they are exchanging. So when you test them, you want to make sure that you are definitely passing in the correct addresses. It can get a little confusing at testing time or unit testing time because you need to validate that the addresses are correct. It sometimes can be a little difficult because these strings are so long for the addresses to miss passing them in. When they're actually operating and users are actually in those roles, it's not as tricky, obviously, because users are supplying that data in some way. Let's take a look at it, though, at this contract. So if we come up here, if we open up our contract here, we can see the code for customer contract. So again, we have that struct for a customer. The customer has a first name, a last name, an email, and an address. You can see here how we build that customer. And we have that we have the customer contract name here for the contract. And we have that enum. And we have the functions here to change the status of our enum. So I've already compiled here. And we look here, we see our accounts and our addresses. So this is good. And we are using what's called the JavaScript VM. It's good enough for right now. We have our compiled contract, and we're only running one contract here, and it's already been deployed. So let's take a quick look here. Let's go to the drop down here, and I passed in here the data from the slide that we just saw. So for Pete Best, you can see here, I've already done John Brown, and now this is Pete Best. So I went up and we were given this. So first name Pete, last name Best, the email, and Pete's address. So what we can do here is add the customer. We can click this button. And from down here, we can see the transaction's been mined. It's successful. And we can look at additional data if we need to. That all looks good. So let me clear the console for right now. Now what we want to do is we need to make sure that we are working with the enum. So let's do a customer count. So notice I did a previous customer count and came back 0. So let's click customer count now. And it's still 0. That's interesting. So we need to count the customers only when we are in a particular state. So notice here it says if my status is ready. So if it's opened or if it's closed. So let's get our current status. Okay, so we have our current status here for 0. It looks like that is, and we can see here that let's set this to ready. See if we can get any kind of updates on that. So paste in this contract and step through. And let's see what kind of information we can actually get back for this contract. So start to input this code and follow the steps and of this lab. We'll go over it a little bit later, and you can check it to see how you're doing with this lab. So this is the summary. We looked at the versions and the pragmas, the compiler versions and the pragmas. We talked about integers, boolean, strings, addresses, enum, structs, arrays, and control structures. Here is our assessment. Let's take a look at these assessments. Take a few minutes and try to answer those. Go to your learning materials for the correct answers. And also, please take a look at these resources. And if you require more training, please look into your learning materials for additional training. And in the next session, we will do more on constructs in Solidity. Thank you.